we'll get our table cover in place. And of course the trick here is now that the table cover's there, we got to drill a hole in here, 2 holes actually, lined up with where the T-nut goes. And as I mentioned earlier in the video, so I made this template, and that's what it's for, is I selected this spot right here as the place I want to put the T-nut. I have to figure out now how I'm going to transfer this location from this clear plastic template onto the actual surface of the table cover. Well, I think I'm going to try using this combination square as a way to transfer this location. And what I'm going to do is just make a little Sharpie pen mark down here on the exposed edge of the white cover material. That should give me a reference for where this thing is going to go in the X direction, we'll call it. And we'll extend our 2 lines here onto the white surface. Actually, I don't need to extend them all the way, but just enough so that they'll cross over the place where we need to put them. We need to do something similar here going in this direction. This is a little trickier because I have a lip on this piece of plastic here. This whole thing would have been better if I just had a piece of flat acrylic. What I decided to do is just slide the blade of this combination square underneath the plastic. Well, that worked for the first mark, but if I try to move the combination square up to here to make the second line, it's going to hit the hand wheel. Let me first see if I can find a different square that'll work better. It's got a more compact base than the other one. And I'm not worried about the fact that these don't line up this way, because it can slide back and forth in this T-slot, and I have some latitude there. I want to slide it out just a little bit more than these black lines indicate. And the reason for that is it has to be able to slide out far enough to get into this empty channel here in order to lift the cover off. Now I need to transfer the locations of these 2 holes onto the table cover. I want this one to not penetrate all the way through, but it's going to be coming up through the bottom, so I have to drill it from the other side. And of course, I'm going to use this 4mm flathead screw, so this will just be a 4mm through hole. I think the quickest and simplest way to get this job done, if it'll work, is to use this, what I call my drilling table. Clamps in the vise on the mini mill, and it's useful for jobs like this. This one's really a little oversized for it, but I think I can make it work. I just need a couple of C-clamps to hold it in place. So what I need to do is line the white cover up so that the area that I want to drill is located in this cutout here. Alright, I've got it clamped down. It's pretty rigid, especially over here where I'm going to be drilling, so I think that'll work. I have done a video on this little table here, drilling table, and it's a handy feature. You can see, just you don't have to take the time to remove the covers and remove the vise and all of that and then put it all back on and get it lined up. This back edge here is carefully machined or set up so that when this is clamped in the vise, this is parallel with the table. Now the real test will be, do I have enough throat depth to move this back far enough to drill it? And I may not. I didn't quite think about that until now, but let's crank it back and see where it ends up. I like using the mini mill as a little drill press for jobs like this, but it does have a pretty limited throat depth. That's usually the gotcha. I think it's going to be a gotcha here. Well, it's close, but not quite, but I may be able to swing this around in the other direction and get it done that way. We'll see. And if not, we'll go to plan C. This is plan B here, and that's not going to work either. Okay, so I guess we got to go to plan C. Alright, well, plan C is going to be this alternate table, which is used for similar jobs. It's actually made for a slightly different purpose, which is milling along the edge of a flat piece. For example, if you have a piece of flat stock, you know, maybe some thin aluminum sheet or some plastic or something, you want to get a clean edge on it. That's what this was set up to do. But it clamps in the vise like the other one, and it's square. But what it doesn't have is the reference edge. Okay, this might work. I flipped this around. This has 2 orientations, and I intentionally put the mounting clamp off center so that I can flip this around one way or the other and move it farther back or farther forward depending on what I'm trying to do. I've moved the drill up here so that it's clear of the edge. I can just clamp that down. It doesn't really matter if it's square because we're just drilling one hole to start with. So it only needs to be square when we drill the second hole. So we'll go in first with a center drill. If you need a set of small metric drills, I got this set a few years ago from Grizzly. It goes from 1 to 6, but in tenths of a millimeter. This has really helped me with a lot of metric projects because I don't have a huge amount of metric tooling, but I'm using metric more and more. We'll find our 4mm drill. This is our through hole, and we're clear of the table below. While we're set up, I want to countersink this hole for the flat top screw. I like to run my countersinks pretty slowly. This material also, I just found out when I grab the drill bit, produces a lot of friction and heat in the drill bit. Maybe a little more. And I actually want the top of this screw to be a little bit below the surface, and it's not there yet. I'm going to use a magnet to see if I can retrieve that. Not with that one. Let's try a stronger magnet. Yeah, that did it. Check it out again. You know, it still feels like it's catching, which makes me wonder if this ruler is slightly magnetic and is actually lifting it up a little bit. I found this little 1/8 inch tool bit, you know, which is precision ground on 4 sides, so it's very flat and it's catching too, and it is not magnetically attracted to the other 2 rulers. So I'm going to take that as an indication that we're still a little bit above the table, although I sure can't see it looking at it. You can see there's an edge there on the far side, so it's definitely below there, but it's certainly catching still on this side. So we'll go a little deeper. If you get it too deep, of course, it'll start to be a place where chips like to catch. Well, out of curiosity, I took this screw over to my stereo microscope and examined it. Thought maybe there was a burr sticking up on it or something. These are pretty high quality screws. I get them from Bolt Depot online, and I've gotten a lot of metric and SAE hardware from them. I've been very happy with all of it. One of the nice things is that they'll package it for you in quantities that are useful to the hobbyist or the hobby machinist, as opposed to having to buy a box of 100 or 500. Let's try again here. Alright, I think we're clear now. That's good. Okay, well, after a little bit of finagling to get it lined up with the T-slot, it appears to do what it's supposed to do. And of course, once I get the guide pin in, that will keep it lined up with the T-slot, and it should slide in there easily every time, right? But we can pull it back and lift it off. The pin is going to go on the inside, or that is closer to the center of the table, so we want it oriented like that. When I drill these 2 holes on the mini mill, I use the DRO to space between them, so they should be exactly 8 millimeters apart. This time we're going to drill in from the back side, but we're going to use the existing hole as a point of reference, and then we can measure off with the DRO to position the hole for the pin. So I'm going to use a spud. It's just a piece of round stock that's been turned in the lathe to a conical point, but they're very handy for situations like this where you need to line up the spindle with an existing hole, and you don't want to go to the time or trouble of using a more sophisticated method like a wiggler or an edge finder. Well, you really couldn't use an edge finder in this situation. But it's not as precise as some other methods, but for a job like this, it's good enough. Now I'll set my x-axis DRO to 0, and then we'll move over 8 millimeters, which is the spacing between the 2 holes in the P-nut, and that will give us the position for our second hole. So I'm watching the DRO here as I move the table over. I'm coming up on 8 millimeters. And there we are. So now I'm going to lock the table down just so it doesn't move while we're drilling. Just as a double check, I'll put the T-nut here, and you can see that that spacing looks correct. So our new hole will be drilled right there. And as you remember, we don't want that to penetrate through the other side of the table cover. So I'm going to drill that to a depth of just 5.0 millimeters. The thickness of the sheet is 7.4, so that should give us enough clearance. Drill bits like to wander sometimes because of their length and limber character. I like to start my holes with a center drill, and that gives the twist drill a point of engagement so that it stays on track. So we'll drill that out just a little bit. Zero it to the surface here, and then watch my DRO and just go down 5 millimeters. And that is all it took. Let's see if it fits now. There we go. So the only other thing I have to worry about is whether I have too much pin sticking out here to fit in the hole in the T-nut, but we can actually maybe test that right now. Looks good. The pin keeps the T-nut lined up with the T-slot, so it should slide right in. And then we'll lock it with this locking screw. Okay, that went well. Now let's lock it down. And it's tight, but it's not locking up. And what I suspect may have happened, it may be that when I tapped the threads, I didn't go deep enough for this screw. So I'm going to try a shorter length of screw and see if that takes care of the problem. And I may want to re-tap that hole and tap it a little deeper. That's about the right length screw. I don't want it to be too short or we won't have any threads engaging. Well, I need to pull the pin. Now I'm glad I didn't use any Loctite on there yet. So I've just got it clamped in the drill chuck here. There we go. I think I'll try putting this back in place without the pin and see if it will tighten up before I go to the trouble of shortening the pin and then finding out that's not the problem. But I've tightened it down snugly. Guess what? It still doesn't tighten up. So I'm glad I decided to check this before I cut the pin shorter, because that's not the problem. There's two possibilities, I guess. One is that I did not tap the hole for the screw deep enough. I took the T-nut out like this, and when it's not engaged with the table, I was able to tighten it all the way down, and it's snug and tight. So it's not the depth of the screw thread that is the problem. So my conclusion now is that this stem of the T is too long. Well, one thing I've learned over the years through making many mistakes is that it's better to check your assumptions before you start removing metal. As I like to say, it's easier to remove metal than it is to put it back, so measure carefully. Just to check my assumptions, I took the smaller T-nut off of the mini-mill table cover, and it has the same spacing between the pin and the screw as this one, so it sort of fits. And I thought, well, let's see if that one will lock up. And it does, in fact. It locks up very tightly, and it actually gives me confidence that one T-nut is going to be plenty for this, because even with this smaller T-nut and smaller screw, it's on here pretty snugly. So I'm pretty sure that what needs to happen here is I need to mill down this top. Of course, that's going to make these two holes shallower, so I may have to do some follow-up work there to correct that. Just as another check on my assumptions, I decided to bring the smaller T-nut from the table cover of the mini-mill over, and it has the same spacing between the screw and the pin as this one, so it sort of fits. You can see that it's quite a lot shorter than this one. Put the T-nut here in the T-slot, and I put a piece of spring material under it, so it's forcing the T-nut up as far as it will go. You can see that when it's all the way up, it's actually protruding above the top of the table here. So that's the problem. So I brought my old analog height gauge here, or dial height gauge, and I bought this one from Grizzly around 20 years ago, and used it for a long time until I got the digital one. But I still use this occasionally, and it's good for jobs like this where you have a kind of a tight space and you want to just measure a height like this. So I'm zeroing it to the top of the table, and it's analog, so you actually have to turn the dial. And then I bring it over to the top of the T-nut here, and it's just about 12 or 13 thousandths above that surface. So I'll take off maybe 15 or 20 thousandths and see how that goes. Now, one potential problem is if I shorten the top here, it makes these holes a little shallower, but I don't think that'll be a big deal, but we'll see. I think I'll use a handheld countersink here to clean up these holes. And I'll take it over to the sander, clean up the edges. Okay, so I've got it all cleaned up on the sander. That end mill does a really nice job. Well, this is the moment of truth, guys, so let's see if we can get this. It slides in there nicely. That's how it should be. You can lift it up, drop it down, line it up with the thing there and slide it in. Pick up the wrench from the floor and we'll tighten it down. And there we go. I think one T-nut is going to be enough. So it's got just a little bit of wobble, but I don't think it's enough to really matter for a table cover. Let me just try sliding it down a little bit more so it hits up against the vise, and maybe that will take care of even that small amount. That did it. Okay, it's kind of rock solid now. That's great. Alright, I'm happy with that. It took longer to get there than I like, but that's the way things usually go. You know, with Murphy here by my side helping out at every turn and get those scribe marks or pen marks off of there. May take 2 passes. It may even take some acetone, but as I said, this material is pretty resistant to everything, so yeah, it's going to take something else. Let's see what I've got over there. Let's try a little acetone, see if it stands up to the chemical abuse.